I started this recording before, but I messed up in so many different places. I'm restarting, but I already have some work done, so I'm not going to erase it. I'll just explain it. So we're looking at the second part of Lab 5, and when we do that, I am going to reuse some part of the first part of Lab 5 just so I don't have to retype it. And speaking of reusing, you always want to try to write your programs modularly. That is, write bits of code that you can test, a small bit of code that you can test, so you don't have to test the whole program each time. It makes it easier to debug, to find out where your problems are if you write smaller modules that you can test individually. In this particular lab, it's really small already. There's no way to really divide it up, but that's just kind of a tip for going forward, is to always try to program modularly. So I am going to copy the constraints from the first part of project Lab 5, just so I don't have to type this over again, and I'll reuse those in the second part. Okay, so now we will do Lab 5_2. Already exists, right? Because I practiced this. So Lab 5_2_R. RTL project, do not specify sources. That's good. Okay, family Arctic 7. Package CPG 236. Speed -1. And then we want this middle one. And you can find all this in the Moodle page. In lab resources, if you look at using Vivado with the Basis 3 board, all of that I just went through is all right there. So it all tells you all what you need to do. Okay, next, finish. Yeah, I'm going to close that. Okay, I'm going to add my source file, and I'll create a file, and I'm going to call it XYFF because we are supposed to be creating this new flip-flop called an XY flip-flop, and what you'll have in your lab will be one set of things to do depending on what X and Y are. I'm not going to do the same thing, obviously, but I'll do something similar. So XY, okay, finish, and okay, and yes. And then I'm going to add a constraint file. Add or create constraints, yes. Create file, XYFF, okay, finish. And for that constraints file, I'm going to paste in what I copied from the previous lab. And let me just open up the sources file. Okay, now I wrote this earlier when I tried to record this before. So here's what I made up for our XY flip-flop. That for our XY flip-flop, if X and Y are both 0, that'll be a set, and Q star will be 1. If X is 0 and Y is 1, Q star will be 0, that's a reset. If X is 1 and Y is 0, that'll be Q bar, a toggle. And if they're both 1, that's also a toggle. And so you can see that we have 4 different possibilities here, each one corresponding to a different 2-bit binary number. Now, I can treat X and Y as a 2-bit binary number by writing it as XY in curly brackets. So I can use that. So one way that I can write this program is by using a case statement. I could also use a bunch of ifs and elses. I could do if X and then nest in that if Y. or I could do if x equals something and y equals something. But the case statement makes a lot of sense here, and so that's what I am going to do. So module x, y, ff. Our inputs are x and y, and clock, CLK. Our output is Q, semicolon. And I'll erase that they put in there for me. And my input is x, comma, y, comma, CLK, semicolon. My output is reg Q, because I'm going to assign it in an always block. Always blocks are very good for sequential circuits. And we're also going to use non-blocking assignment, which also is good for sequential circuits. I talked about that in the previous video. Now I input this. Our form is always really important to be able to read the programs. You always want to indent each time you start a new block. So module and end module, that's one level. And so that level is our outside level, and then I'll indent to get to our next level. And then the next thing I'm going to have is my always block. So always at positive edge. I could do negative edge, but I'm going to do positive edge clock. And then if I were to have more than one line in here, I would need a begin and an end, but all I'm going to have in here is a single case statement, so I don't need a begin and an end because I'm just going to have the single case statement. So I'm going to have case, and the case is going to be based on the 2-bit combination of x and y. So I have case like that, and then and again, notice how I'm indenting for each new set. I'm going to have at a different level. My first case is for the binary number, so that's 2'B00, and we said that one was a set. So for that one, we will have Q, and then use the non-blocking assignment, so Q becomes 1, semicolon. Now our next possibility is the binary number 0, 1, and we said that was a reset, so we'll have Q becomes 0. And then our next one, 1, 0, we said Q was going to toggle, so will become not Q. And same was going to be true for 1, 1. Now those are all the possible 2-bit binary numbers. Oh, look, see I have an error. I need a semicolon up here. But I'm going to go ahead and put a default in anyway, just good practice. So my default, and let's have our default just be Q becomes Q. And then that's end case. I think that's lined up. And then that's also the end of the always block and the end of the module. So I've got everything there. Okay, so now let's check the constraints. So we have 2 inputs. In this one we only had 1, and it was D. So I'm going to copy this. And my first input is X, and my second input is Y. Now let's figure out what switch we want to use. So if you look here at the bottom, we were using R2 for X, and so T1 is the switch right next to that, so we'll use T1. So instead of R2, we'll use T1. Q, that's the same name, and clock, that's the same name. So we have everything there. Everything looks good. I don't see any errors. I am going to open elaborated design. Okay, so I get one critical warning message. I'm expecting that because of the clock. That's what happens when I have the clock. I'm going to say, okay, let me look at my design. Do I have one flip-flop? I'm supposed to have one flip-flop, and I do. I have one flip-flop right here. I have a multiplexer. That makes sense that I have a multiplexer, especially with my case statements. Just kind of looking at it, it looks pretty good. I have ground going in to 0, 1, and that was supposed to be the reset. I have power going into 0, 0. That's supposed to be the set. That's good. I have the NOT gate, so Q NOT going into 1, 0, and 1, 1. So that looks exactly like I would expect it to look. So everything there looks good. Now, because I do have the basis board, I'm going to go ahead and program it. So I will generate the bit stream. I paused it there while it was generating the bit stream. It's still generating it. I can see up here in this top right hand corner that it's still working on it. Okay, so it's done generating that. I will open the hardware manager. And then open target, open new target, connect to local server, and I want to change the clock frequency to this highest one. Finish. Okay, now I'm going to program the device. And it says it's programmed. So let's see if it works. Okay, so or if you watched the last video, you'll remember that we programmed the clock to be this bottom button right here, and the switches that are X and Y are these first two switches, and the output that's Q is the LED up there. So we have with 0 and 0, that's supposed to be set. So if we press the clock button, the light should come on. Yay! The light comes on. Okay, and 0, 1 is supposed to be reset. So I'll turn that switch, and then it looks like the light's still on because I did not turn the right switch. There we go. And the light is off. Okay, and 1, 0 is supposed to be toggle. So 1, 0, so it's supposed to be toggle, so it's off now. So if I press the clock button again, it should come on. And if I press it again, it should go off, on, off. And 1, 1 is also supposed to be toggle. Yay, it works. Okay, so now I don't know how long this has been off. So while it's generating the bit stream, I seem to have stopped recording. I don't know when I last recorded. So I'm going to go back and show you what I did. I don't know how much of this I hope I recorded some of it. Okay, so the first thing I did was I got a Carnot map, and so I set up my XY 0, 0, 0, 1, 1, 1, 1, 0, and 0, 1, and then when XY was 0, 0, that was a set, so my Q should be 1. When XY was 0, 1, that was a reset, so that's 0, 0. With 1, 0 or 1, 1, 1, 1 or 1, 0, those are both toggle, so when Q is 0, I should get 1. When Q is 1, I get 0. And then from my Carnot map, I grouped those, and I grouped those. And so this up and down group, that's X bar, Y bar. X, so not X and not Y. And this horizontal group, that's X, because X is 1, and not Y. Oh, that's wrong. And I'm glad I came back. This is not going to work. So let us fix this. And yeah, so this will not work because I got the Carnot map wrong. So let's fix this. So this should be X and not Q. All right. So let's go back here to my program. So I'm going to cancel the bit stream. And I'll go back to my source, and I wanted not X and not Q. Okay. I'll save that, and I will do a new elaborated design. This may be where I paused it last time. Okay, so we've got our Q coming back here, so that's not Q, that's not X. That's what we want. We have X and not Y in the OR, so that looks good. Okay, now generate the bit stream. Okay, so open the hardware manager, program device. And let's see if it works. So remember, that's our clock right there. So 0, 0 was supposed to be set. Right now the switches are both 0, 0, and nothing is happening because the switches were not 0, 0. That's interesting. Huh. Well, at this point, y'all are probably all saying, yeah, you messed up the Carnot map again, and it's not X and not Q. it is, so this circle right here, I need to go back to digital logic 1, right here, that is X and not Q. So X and not Q. That's what it's supposed to be. Now notice these errors I've been making, those are logic errors, so we don't catch them until we actually are running the thing. So take that not out, and I will save it, and then I will pause. Okay, let's try this one more time. And I will go to program device, that device. And let's see. Okay, right now they are on 1, 1, so that's supposed to be toggle, and that is toggling. Yay. Okay, now 0, 0 wasn't that supposed to be set? I don't remember now and I threw it away. Let's see. 0, 0 was supposed to be set. Let's see. Okay, alright, I quit. Alright, so y'all just, I will, like, resign and y'all can get a new SI. Okay, so, obviously this first column is not X and not Y. That's this first column. And this horizontal one is X and not Q. So, I did it wrong again, and I'm actually not going to go back and fix it, because you're not going to learn anything from that. But you did learn that I did make lots of mistakes. So I might go back and redo this, and I might not. But I hope that what I did was helpful, if not for the not being able to write a characteristic equation. So see you next time. Bye.